1. Okay? Now, when you see a diagram, like the first one there, first thing, you must look for a center. You look for a cyclic chord. You also look for tangents. Remember, we have got 3 categories of theorems: center theorems, cyclic chord theorems, and tangent theorems. Okay, it's not that difficult. Okay, it's not that difficult. We have got 3 groups of theorems: center theorems, there are 3; cyclic chord theorems, there are 3; tangent theorems, there are 3, plus the 3 corollaries. Okay, together with the inverses of theorem 1, theorem 4, 5, 6, theorem 7, and theorem 9. Okay, so here we don't have a cyclic chord, which means we can't use the cyclic chord theorems in this question here. We can't use the cyclic chord theorem. We don't have a center, so we can't use the center theorems. Okay, but we have a tangent, which means we might need to use the tangent theorems. Also, we have a triangle inside the circle, which means your knowledge of triangles from grade 8 and 9 is required. Okay, so here, this angle is 70, that angle is 50 degrees. Okay, for some reason I think the screen is also supposed to not see. Anyway, are you seeing it properly at the back? Yes. Right. So I want to get x. My x is this angle. Okay? And we have a tangent there. Now this tangent and the chord AB, they form this angle which is equal to 70 degrees. Now this tangent here, it subtends angle C, which is equal to x. Therefore, x is equal to 70 degrees. And our reason, theorem 9, tan chord theorem. So my first thing is to say x is equal to 70 degrees. My reason, tan chord theorem. Okay? You follow me there? Then we have this angle, which is equal to 50 degrees. It is between the tangent and that chord. And this chord AC subtends angle Y. So we have a chord which subtends angle Y or angle B. That chord causes the formation of an angle which is equal to 50 degrees. Therefore, Y will be equal to 50 degrees because of the tan chord theorem. Right? Because of the tan chord theorem. So Y is 50 degrees. Alright? So when you see a tangent, identify a chord inside the circle. That chord, if it subtends an angle inside the circle, is at the circumference. And it also causes the formation of another angle with the tangent. Then you can say, therefore, I'm going to use the tan chord theorem. Alright? So that's this one here. So let me draw the division line. Let's move on to that. Now this one, we also have a tangent and a triangle. And we have a set of parallel lines, that is AC and DB. Okay? We want the size of angle X, Y, and Z. Okay? Now I can get X quickly by using grade 8 and 9 knowledge. Okay? Getting X is not grade 11, grade 8 and 9. Because we have a line which is parallel to AC. BD is parallel to AC. Therefore, this chord, BC, is called a transversal from your grade 8 and 9. So, angle X is equal to 57 degrees. Alternate angles, sorry, 67. So x is equal to 67. So we write here x is equal to 67 degrees. You're using alternate angles. And then you must state the lines that are parallel. So you say AC is parallel to BD. Okay? So I now know what x is. Now I need to get y. Okay? I need to get y. Now to get y, I have this angle here between a chord, sorry, a tangent and a chord. And this chord subtends angle A, which is equal to y. So I can use the tan chord theorem. So we'll say y is equal to 67 degrees. The reason, tan chord theorem. So we now know what x is and what y is. It is easy to find what z is. Okay? I'm not going to complicate how to find z. I'll use my knowledge of grade 8 and 9, geometry of straight lines. This angle and that angle, they are alternate. Okay? Since they are alternate, it means y is equal to z. So z will be equal to 67 degrees. And my reason, alternate angles. AC is parallel to BD. If you don't want to use geometry of straight lines, you then need to use your knowledge of triangles. You add x and y to get the size of this angle. Then you add 67 plus that, plus z, you must get 180. But that's a longer method. But it will give you the same what? The same answer. Okay? But I prefer to use my knowledge of geometry of straight lines. So angle y is equal to angle z. Therefore z is equal to 67 degrees. Alright? If you want here, you can add y here equal to z. So that equals 1 equal to 67. Okay? So when you write your test next week, right? Sorry, in almost like 3 weeks from now, right? Right? When you write your sorry, are you forgetting that you are in the lesson now? When you write your test in 3 weeks' time, approximately, if you get a question, ask yourself, is there a center? If it's there, you're likely to use one of the center theorems. Is there a cyclic part? Do I have 4 vertices on the circumference? If they are there, the cyclic part theorems. Theorem 4, 5, and 6. If there is a tangent, it means you're supposed to use theorem 4, theorem 7, 8, or 9. Okay? Now, if you have got a positive attitude and you practice, I tell you what I'm saying won't make things difficult for you. If you see the diagram, ask yourself, which group of theorems do I have in the question?
Sir, I will only write consistent theorems.
Yes. Because so far, that's the only topic you have done.
Sometimes when I incorporate
No. There is no connection between term 1 way and the geometry. Right? So you write geometry on its own. Alright? So it's not that difficult. Alright, let's carry on. Can you please do me a favor? You need to keep quiet now. Ask about the questions that you have here. So we have another set of questions. Alright. So again in question 3, you're supposed to find x, y, and z. Okay? X, y, and z. And we have a tangent, KT, we also have a tangent, KP. So we have two tangents and we have a diameter. Now, the moment you have a diameter, it means theorem 3 must come into your head. Angle in the same set. Okay? The moment you see a diameter, it means, okay, theorem 3. Which means you might need to use it to do the question. And you have got two tangents, which means you might need to use theorem 7, 8, or 9. Sometimes I feel like geometry is not that hard, right? Because, you see, if you are listening carefully to what I'm saying, that if you get a question, ask yourself, do I have a set? Okay? Do you have a center here? Yes. If the answer is yes, means you are supposed to use any one of the three center theorems. And one of them is theorem 3. Do we have a cyclic quad? Yes. Do we have a cyclic quad? No. Okay. There's no cyclic quad here. We have 1, 2, 3 vertices at the circumference. There's no cyclic quad. If there is no cyclic quad, it means forget about theorem 4, 5, and 6. Forget about them.
But can they give you one with all nine?
So what is that one?
No, you cannot get a question where you need to use all 9 theorems.
I can't see what that is outside.
Alright? So with a triangle inside the circle, means you can't use the cyclic quad theorems. But we have got two tangents, that is PK and KT, which means you can use theorem 7, 8, or 9. Yes? One, they are drawn from the outside the circle up to the circumference. And they touch the circle at one point. Okay?
So what is the thing? The points outside the line. Outside the line, like later. What's name?
I'm talking about this point here. I think I have to go back for you to see. Wait. S. Okay, yeah. S. So that's point S then. Alright, so we've got a center, means we might need to use the cyclic quad theorems. Sorry, the center theorems. There's no cyclic quad, we can use theorem 4, 5, and 6. They are tangents, which means we may need to use theorem 7, 8, or 9. Okay, so we want to get x, y, and z. Now, since we are given this angle here, okay, we are given this angle, which is 50. That's the only one which is given, right? The only way is to get the angle y first. Okay? You have to get angle y first. Or you can get x as well first. Okay? Because the two tangents, they start from the same point. So that's theorem what? 8. Turns from a common point. Theorem 8. Tangent from the same point. So I'm going to get x first. Okay? So I'll say, first thing I have to say that PK is equal to KT. My reason turns from same point. Okay? Please, that's where you're supposed to start. You have to mention that the PK is equal to KT because they are tangents from the same point or from a common point. Then after that, then you can say x is equal to 50 degrees. And your reason angles opposite equal sides. Okay? X is equal to 50 degrees because the two angles x and 50, they are opposite equal sides. And the two opposite equal sides are PK and KT. PK listen carefully. PK is equal to KT. Do you understand that? Huh? Do you understand that, all of you? Then it means that KT is equal to PK. Do you see that angle X is opposite KT and this angle of 50 degrees is opposite PK? That's why we say they are angles opposite equal sides. Angles opposite equal sides are equal. Angles opposite equal sides are equal. And also, sides opposite equal sides are equal. Okay, sides, sorry, I think I didn't put angles. Opposite, sides opposite equal angles are equal. There is angles opposite equal sides, then there is sides opposite equal angles. Alright, okay, let's get on. So we have got X now. Now after getting X, I can now find Y. Okay? My Y, there are two ways of getting it. Because we have got PK, it's a tangent, and we have PT, which is this chord. Okay? PK and PT, they form this angle. And PT is opposite, or it subtends angle S, which is equal to Y. So, angle X is equal to angle Y. They are both equal to 50 degrees. My reason, Tangent Theorem. Okay?
So you can get it wrong if you don't state how you want it.
In geometry, you are supposed to write a statement and a reason. Statement and a reason. By now, as you are expected to know that. Yes. Which one? Alright. Can I have your attention? X is equal to Y because this tangent PK and chord PT, they form angle X. At the same time, chord PT subtends angle S, which is equal to Y. Therefore, X is equal to Y based on theorem 9, which is the tangent theorem. Or you can say this angle and that chord KT, they form this angle which is 50, and this chord PT subtends angle S, which is equal to Y. So Y is equal to 50 degrees. So you can use both sides, or you can use any of the two tangents. That is PK or KT. You still get to 50 degrees. As long as there is a chord inside the circle that is involved in the formation of two angles, one on the circumference, which is subtended by that chord, and another angle between the chord and the tangent, then you can use the tangent theorem. Are you following? Yeah. Right? So let's find Z. Now, Z is easy to find. Okay? Z is this angle. Right? Z is that angle. So, to find Z, I'll say in triangle PST, okay, in triangle PST, right, angle Z plus, in fact, let me write this first. I'll say, you see this angle, it's angle T1. Angle T1 is equal to 90 degrees. And my reason angle in semicircle. Because PS is a diameter. An angle subtended by a diameter is equal to 90 degrees. Okay, this angle here, that angle is equal to T1. and it's equal to 90 degrees because it's an angle subtended by a diameter. Then I'll say in that same triangle, if I add z plus y plus t1, I'll get 180 degrees. And my reason, sum of angles in a triangle. So my z is equal to 180 degrees minus 90 plus 50 degrees. So I'll get z as 40 degrees. Okay? Then you are done. I always encourage you, if you are answering geometry questions, it's better for you to provide more information than less information. It's better to provide more information than less information. Okay. Anyone else got a question? Alright, let's move on to question 4. Question 4. Now, question 4 says, question 4, you have a triangle inside the circle, and you have got two tangents. Okay? There is no cyclic part. So you can't use theorem 4, 5, or 6. You might need to use 7, 8, or 9. There is no center. Okay? So you can't use theorem 1, 2, or 3. Which means you only have to use any one of the three tangent theorems together with your knowledge of triangles, because there is a triangle. Okay? So if I'm given this angle here, it's 40 degrees. Okay? So I can find x, okay, by saying in triangle, in fact, let me write this first. I'll say mg is equal to ng, and the reason turns from same point. Okay, by the way, that word turns is the shortcut for tangents. Okay, you are allowed to use it. So turns from same point. What I'm trying to say is that this side here and that side are equal. Okay? Therefore, I can say angle G plus angle X plus angle N1, they add up to 180 degrees. Then I'll write here sum of angles in the triangle. Okay, I hope you can see that angle X is equal to angle N1 because they are angles opposite equal sides. Okay, so what this means is that where there is X here, I can put N1, or where there is N1 here, I can put X. But since I want to determine X, I'm going to put X where there is N1. If I do that, where there is G here, I'll put 40 degrees. Where there is X, I'll put X. Where there is N1, I can put X there. And that's equal to 180 degrees. The reason why I'm putting X where there is N1 is because I have proved that X is equal to N1 because they are angles opposite equal sides. So I can write here 2x will be equal to 180 minus 40, which gives you 140. So x will be 70 degrees. Okay? So now I need to find what z is, what y is. Okay? Now, to find y, okay, to find y, it's much better to find z first. Okay? So sorry, it's not Z, it's N2 rather, this is N2. That's Y there, right? So if I want to find Y, right, remember, this is a tangent, so it subtends this angle. So N1 is equal to angle L, okay? And this angle X is a tangent, so since it is a tangent, sorry, this angle X is caused by the formation of this tangent and that chord. Therefore, angle X is also equal to that angle. So it's much better to get the size of angle L. Okay, first, yes?
So, okay, for triangle MGA, why wouldn't you work out the sum of angles in a triangle? Then you'll get N1, and then you say alternate angles. You try to do that, and then you'll see what Y is equal to.
Okay, it's a good thing that you are mentioning, and you keep quiet. You are mentioning alternate angles. Right. I want to warn you from now on. Never make an assumption that LMGN is a square or a rectangle without proving it. You have to prove it first, that it's a quadrilateral. And you have named the quadrilateral. Now that's very complex. So don't mention alternate angles because you have to prove that there are lines that are parallel. And we are not given any lines that are parallel in the diagram. If those lines that are parallel are not there, it means if you want to use that, prove it first that the lines are parallel. Now that will complicate things. So we don't have a square here, we don't have a rectangle, we don't have a rhombus, we don't have a parallelogram. Unless you prove it. Unless you prove it. So if you want to use parallel lines, then you must prove that GNLM is a square, is a rhombus, is a charm, is a rectangle. That's more complex. Okay? Only do that if you are told in the question that this shape is a quadrilateral, like a square, a rhombus, a rectangle, and so on. If you are not told, don't make an assumption. Even if the shape looks like one of the quadrilaterals, don't make an assumption. Because we have to go back to the properties of quadrilaterals. Remember that we did in grade 9 and 10? Properties of quadrilaterals. So for this question here, let's not go there. Right? Let's use our knowledge.
Good afternoon, Kingsman. There is going to be 3
Right, can you do me a favor? I just need to carry on. Right, so we've got X. So this angle here, we can get it by saying that angle X is equal to angle L, and that's equal to 70 degrees. And that's tan chord theorem. Okay? Then angle Y plus angle N2 plus L will give me 180. So I'll say angle L plus Y plus N2 is equal to 180. That's sum of angles in a triangle. Okay? Now, angle Y and N2, they are equal. So I can write this as 2y is equal to 180 minus 70 will give me 110 degrees. So y is equal to 55 degrees. Okay? Please, I want to add this. Angle y is equal to angle N2 because they are angles opposite equal sides. You have to write that down. Okay? So you can see that because it's easier that Lm is equal to Ln. Therefore, y and n2 are equal. And their angles opposite equal sides. Okay? And since x is 70, means angle L is equal to 70 from tan chord theorem. So if I add angle L, N2 and Y, I'll get 180. I subtract 70 from 180, I'll get 110. Then divide that 110 by 2 because Y is equal to N2. And I'll get my Y is 55 degrees. Okay? So, right, I cannot carry on now.
Yes.